Hello, my name is Matthew Lackey, and I am here to do the discussion or documentation for my group's final project for comp thinking. So, for our final project, we did the power consumption in different city zones in an area affected by weather parameters. So, the objectives from this was the scan on power consumption in city areas and how the atmospheric and landscape conditions affect total power consumption. We also want to analyze an existing measurement data set and build data models to predict power consumption in three different city zones. So for our deliverables, we wanted to break down each task into a manageable subtask and describe how you intend to solve each subtask and how you will test each task. So for our first, table, the main goal of this data was to understand how different variables affect power consumption. In the histogram, all three zones tend to lean towards being right skewed. This implies that most of the data is low to medium range with some high spikes. Wind speed does not seem to follow any clear pattern, while temp is somewhat normally disrupted, while humidity tends to lean towards higher values. All this data shows that while power consumption is affected by outside factors, it does not line up perfectly. So for the correlation heat map, this heat map visually shows the strength of relationships between all variables in the data set. The darker colors indicate stronger correlations, helping identify which weather factors are most related to power consumption. It calculates correlations between all numeric variables, displays correlation coefficients directly on the heat map. Positive correlations indicate that two variables tend to increase together, while negative correlations indicate that one variable decreases as the other increases. Or actually, let me start by saying the heat map is used to measure how strongly variables are related to one another. Darker colors represent stronger relationships, making it easier to quickly identify important variables. The heat map also helps identify variables that may contain redundant information. Understanding correlations is important before building machine learning models because it helps with feature selections and improves model efficiency. So as you can see, all the data between temperature, humidity, wind speed, zone 1 power consumption, zone 2 power consumption, zone 3, and as well on the bottom. So, for our histograms for disruption of variables, these histograms show how the data values are disrupted for each variable. They help identify patterns such as skewness, spread, and possible outliers in the data set. As you can see, temperature, humidity, wind speed, zone power 1 consumption, zone power 2 consumption, zone power 3. So for our next histogram, we have temperature versus zone 1 power. This scatter plot shows the relationship between temperature and zone 1 and power consumption. I figure that's pretty obvious and given. The overall trends suggest that temperature has a notable effect on efficiency or electricity demand. So if there's higher temperature, then more power will be needed, as you can see here in the scatter plot. Now, zone 2 power consumption and zone 3 power consumption versus temperature. These scatter plots compare how temperature affects power consumption in zone 2 and zone 3, zone 2 being the first scatter plot and zone 3 being the second scatter plot. These plots help show whether each zone responds differently to changing weather conditions. As you can see, zone 2 and zone 3 do respond differently to weather conditions. In zone 3, it dramatically needs more power for the temperature than zone 2, and when there's less temperature, It does not need as much power as zone 2. Now, for the interpolation of our scatter plots, all of these right here, these kind of show the relationships between temperature and power consumption. I would like to note that temperature appears to have a stronger influence than some other variables, and weaker variables may contribute less to prediction accuracy. This shows temp has a stronger influence on power consumption, more so than other variables. The weaker variables show weaker patterns. All the codes. Now, pair plot visualization. Ooh. Excuse me here. Pair plot provides a complete visual comparison of all the variables in the data set. It helps identify trends, correlations, and patterns across multiple variables at the same time. We use Seaborn pair plot to compare all variables simultaneously. Removes data time column before plotting and numeric values. So let's go to model building. Okay. So for model building, it kind of marks a transition from exploratory analysis to machine learning. Indicates the predictive models will now be developed and evaluated. So for our kind of models, we have weather factors versus power usage, temperature versus zone 1 power. Then we have our models and zones. Then we have our score by model and zone. The graphs in this section compare actual values with model predictions to evaluate accuracy. The visualizations also highlight which machine learning model performed best and which weather variables had the greatest impact on predictions. And that will pretty much do it all. Kind of just a brief little short explanation as to what each, I guess, scatter plot or part of our project is. So, thank you very much.